Okay, so in 12.1, day 2, I told you I wanted to basically help you define this symbol, this symbol, this symbol, this symbol. We want to talk about Venn diagrams and word problems. And you'll see that SAT actually has some of this stuff on it, but they don't use the symbols. They just use the words. Okay, so first thing you need to know is what the U means. So U means the universal set. Okay, and basically the universal set is exactly what it sounds like. It's the set that everything's borrowed from. So for example, think back to your Algebra 1 days. Your teacher would say, solve x squared plus 4 equals 0. So this is in Algebra 1 days. And you're trying to solve it, so you're like, let's subtract the 4. Let's square root. Don't forget the plus or minus. Then you raise your hand. You ask the teacher, what is the square root of negative 4? The teacher said, well, what number times itself makes negative 4? And you said, none. The teacher said, that's right. And if you took the red textbook back in that time, if you had that old Dulciani book that I used in high school, you would have written your answer one of two ways. Either you would have written X is the empty set or the null set. Maybe your teacher would let you write no solution, which is a perfectly valid answer. But one of the teacher's methods was to write this little phi symbol, which means no solution. Well, that happens to be the null set symbol. Naturally it is, because the empty set of the answer is an empty set. There's nothing in it. And therefore, this symbol is perfectly appropriate all this context. When you said no solution, here's what you were saying. The number of answers in the set X is 0. No solutions. The number of elements in the set X is 0. Okay, so no solution. Now, this was because in Algebra 1, you were only discussing real numbers. And that was the universal set. Numbers like rad 2 were perfectly fine. Numbers like root 6 were fine. Negative 4 is fine, right? But not I stuff at that time. So the universal set in Algebra 1 is the real numbers. The universal set in Algebra 1 is the real numbers. Students don't talk about complex numbers at that time. It's too early. Right? But in Algebra 2, when you solve the same problem, and you're asked to solve x squared minus 4, x squared plus 4 equals 0, you would go x squared equals negative 4, x equals plus or minus 2i. Right? Having learned what complex numbers means, you felt like you were allowed to use them, So you'd have two answers, and you could write them in set notation if you wanted to. If you had that green Algebra 2 book, you might have seen this in the back of the book. Or maybe someone just asked how many solutions are there, and you would say the number of elements in set X is 2. There are two answers. And they're conjugates, which you also learned. Okay, now why is it that we're allowing you to use I here and not in Algebra 1? It's because the universal set in Algebra 2 is the complex number system. Now, before you get too, proud or big-headed about, hey, I can do complex numbers, please understand that there are plenty of very advanced math classes that do not discuss the complex numbers, and they only discuss the real numbers. And believe me, real analysis is a super hard class, plenty hard, and has nothing to do with I at all, but it will still stretch you. Okay? So don't feel like all the cool problems come from the complex world. Not only. Okay, there are symbols for these things. The real numbers category has often been abbreviated with a double-struck capital R, as you've seen. And complex numbers, there are many things people use. Some people use a capital C, which is kind of what I use, but there are other symbols used. The universal set. Now, the universal set could be just integers. Okay, so if a universal set is integers, the set U is the set of all integers, in many math books that's abbreviated as Z, double struck Z. I don't know why Z. Why not I, you know? I don't know, maybe they thought I means imaginary or something. But if it's a set of natural numbers, you know, 1, 2, 3, 4, it might be N, a double struck N, you see. And to be honest, I don't even know all of them myself, because I didn't take a lot of abstract algebra in college. But I saw these symbols sometimes, and I wondered, what do these mean? But they're just telling you what the universal set is. So if you see a big fat C, make sure you use I in your answers. If you see a big fat double struck R that's real, don't use I in your answers. You see. Okay, so set notation, universal sets. In the example of the thief going to Walmart from the other day, Walmart was the universe. To that thief, Walmart was everything. Everything he stole was from Walmart, remember that? And we said if you found something in his collection that wasn't from Walmart, then that means Walmart's not the universal set. He got something from somewhere else, you see. So the universal set is basically where everything's stolen from. Okay, so in the SAT, you see things like sentences, you know. You'll see if n is a positive integer, right? How many possible values of n make the statement true? And they'll give you some crazy equation. E to the n squared minus 2n minus 3 equals e to the fourth or something. And you're trying to solve it. And let's say you get all the way down to the very end and you actually figure this one out. This one's kind of a stupid example. Doesn't solve very well at all. But let's say you get all the way down to the very end, you get n equals rad something and n equals rad something. The answer is none. The question says, if n is a positive integer, how many n's are there? They're giving you a universal set. They want integer answers only, and the answer is there are none. Okay? So when they declared this sentence, a lot of people skip over this. This is your universal set. You may not give radical answers. You're only allowed integer answers. So the answer is none. Not 2. Even though there are 2 solutions, they are not integers. See? If it says n is a real number, then this probably has 2 solutions. Does that make sense? Hopefully. Okay, you probably won't see E on the SAT, but you might see 2 to the something, you know. All right, so that's universal sets. Okay, and I told you I also wanted to teach you what this symbol meant. This is not universal set. This is union of. Union of. So it's a command, actually. So if you see, let's just do this by example, it's easy to learn. Let's say that A is the set 2, 3, 4, and B is the set 4, 5, 6, and I say find AUB, you're going to unite the sets. So that means make one from the many, right, to unite. So you're going to be putting A and B into one long set. So you're going to take everything that A has and everything that B has and glue them all together and make one big set, namely the set 2, 3, 4, 5, 6. Now the 4 shows up twice, but you don't repeat because one of the rules of sets is that you don't have any repeats. Okay? No repeats. All right, let's talk about this symbol. This is pronounced intersection of. Intersection of. Let me put that actually at the top of the board here. So if I ask you to find A intersect B, that is actually a very small set. What you're looking for now are elements that A and B both share. So look at the two sets. What do they have in common? The answer is they only share a 4. So typically an intersection set tends to be smaller than the original two sets, generally speaking, not always. But union sets are big, intersection sets are smaller, because they're like common elements. It's kind of like the idea of LCM and GCF. Those are opposites. Okay, the U symbol you'll see when we do probability is actually pronounced OR, and the intersection is pronounced AND. Okay, so be flexible with these. Sometimes you'll see the word both, and on this one, the word either. So I'm just trying to help you understand that in a word problem, you might see the word or, you're not going to see a symbol, right? You might see the word either, right? Those are sort of the same idea. And then if you're doing a word problem that involves some kind of intersection, it's probably going to use the word and or both or something like that. Okay, any questions on that? Okay, and then the third symbol I said I wanted to teach you, well, the fourth, if you count the capital U for universal set, is this bar thing. So the bar is kind of like the negative symbol in this world of math. So if I said, this means not in the set K. So if you see bar K, it means not in the set K, is how it's pronounced. So let's do an example. Let's say that you have K is the set 2, 4, 6, 8. And the universal set is 2, 4, 6, 8, 10, 12. Those elements that are not in K are anything in the universe, okay, that K doesn't have in the means. So here's your universe, 2, 4, 6, 8, 10, 12. That's it. Small little department of options to pull from. You may never introduce any other numbers in this problem. 2, 4, 6, 8, 10, 12 is the universe. Now, what does K not have? Doesn't have a 10, doesn't have a 12. So that's called the not K set. Okay? So notice that whenever you have not K, the number of elements in that are going to be the number of elements in the universe minus the number of elements in K. Or another way to write that would be to write this. The number of elements that are in a set plus the number of elements that are not in a set always adds up to all the numbers available to all mankind. Right? It's like saying there's two kinds of people in this world. Those who love fuzzy green hats and those who don't. Right? That's one way of classifying humans. Right? Those who love fuzzy green hats and those who don't. So if you add the number of people who love fuzzy green hats and those who don't, you get the population of mankind. Does that make sense? Okay, so this is kind of our first little theorem, I guess you could say. You can't like fuzzy green hats and not like them at the same time. We'll just assume that, okay. Okay, so let's just do a practical real-life problem here. Okay, so I'm going to write it in a sentence format so that it's not so much, I guess, obvious, you know? So let's do a Mr. Shore's class example. Mr. Shore's 4th period class contains, and let's see here. Raise your hand if you're right-handed. oh man, this might not work. It's too many. Raise your hand if you're a girl. Okay, 1, 2, 3. Hold on, you got to keep your hands up because this won't work if it doesn't count out right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 girls and 12 boys, because I have 26. Raise your hand if you're taking chem, any level of chemistry. Keep your hand up. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's kind of awkward having 12. I don't want to have any duplicate numbers. It'll mess up. My equations won't be easy to understand. Let's switch it. Let's do, I was going to do A push and chem. What can we do?
A push in English.
Okay, but everybody's in English, right? Let's do AP Bio. Raise your hand if you're in AP Bio. Okay, so 1, 2, 3, 4, 5. 5 students are in AP Bio. And raise your hand if you're in A push. 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. I can't count you guys. Keep them up high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students are in A push.
Wait, it's 12 again.
Yeah. How about,
Physics.
well, see, I have to have some overlap kids. Like, is anyone in physics and chem?
Yeah.
Oh, this will work then. Let's just do physics and chem. I'm sorry. No, because I have 12 chem students. You guys are messing me up.
If you do physics 1 and you do bio, you'll have an overlap.
We're just going to make up some numbers. Because I can't have more than 112. It's just not going to work. I mean, it'll work, but it's confusing. So,
Physics and bio.
you think that'll work? Is anyone in physics and bio? 2. All right, we can do that. So how many in physics? Raise your hand. Sorry, guys. Did I already count this? 2. So 2, 4, 6, 8, 10, 12, 14. So 14 students in physics. 14? Come on.
Ask one of the physics.
Just ask how many people are playing
How many in
sport.
physics C? Nobody. How
How many people are playing a sport? I'm in physics C, yeah. I'm in physics C. Oh my goodness.
Okay, here. Let's do the bio. How many were in bio? One more time. AP bio. 5. That's what I thought. Okay. 5 in AP bio, and let's do sports. That's a good idea. This worked so well in the other classes, but okay. How many are in a sport? Yeah, you got to raise your hand or it'll mess up my count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yay, we have some new numbers here. Just want to make sure that we have an AP Bio student that's actually in a sport, just in case. Okay. Any AP Bio students that are not in a sport? Okay, great. This will work. Okay. 4 students are taking AP Bio and are also in a sport. Oh, okay, we finally got our problem drafted up here. So there's two ways of finding out how many people are in Mr. Shore's class. Okay? So let's define everything first. The universal set is defined as all students in Mr. Shore's 4th period class. It's really important that you write that whole thing because you don't want to say it's all students. That implies other kids outside this room. You don't want to say in Mr. Shore's class because I actually have, 112 students, whatever, 120. We only want to talk about Mr. Shore's 4th period class. This is the universe. okay? Any other sets we write down have to be subsets, proper or otherwise, of this universe. Okay, so B will have to mean, in this case, all boys in Mr. Shore's 4th period class. You don't want to just put all boys. G, all girls in Mr. Shore's 4th period class. Bio, AP Bio, we don't want to use B again. Let's set AP. Is that class tough? Is AP Bio tough? Is it a hard subject?
Wait, I heard
Tough?
a
Okay, we'll call it T. T for tough.
No, I heard a rumor that it's a possibility you could teach physics. Yeah.
All students in AP Bio.
Because Mr. Shore would be a very good physics teacher.
Okay, and then sports. I guess we can use set S for that. So you got to be careful. It's not all students in bio. It's all students from you that are in bio, right? So all students from Mr. Shore's 4th period in bio. Very important, right? You don't want to just say all students in bio. Set S is all students from Mr. Shore's 4th period in sports. So if you look in the textbook, a set always has to be well defined. I skipped over that the other day, but it shows up right here. You need to be very, very clear what you're talking about, right? Some statistics can be very misleading. You might hear things like, most teenagers in America like chocolate. Who's the universal set? American teenagers, right? It's pretty well implied there. But you could actually word it in such a way as to convince someone of something, but your definition of the universal set isn't clear, or your definition of a subset isn't clear. So you can actually mislead people. Might be like a marketing strategy. You can actually make people think, like for example, America's #1 choice of potato chip is evidently Calbee. Calbee. When I was in Taiwan, we had Calbee potato chips. How many of you have ever heard of Calbee potato chips? They're really good. You can get them at 99 Ranch. You know what it says on the package? America's favorite chip. How come you've never heard of it? Well, evidently the sample size was 5 or 6 Americans living near the factory. And they're like, hey, which of these chips do you like best? Oh, I like that one. That's America's favorite chip. In our little America with 5 people. See what I'm saying? So the sample size isn't clear, the universal set isn't clear, and you've never heard of Calbee except for 2 of you. You like Calbee chips? You've heard of them. Have you had them, Kathy? Oh, I thought your hand was up. Try Calbee chips. They're amazing. They might actually be your favorite chip. I like the steak and onions one. I'm just kidding. There's no steak and onions. But there's a lot of interesting names for it. Wasabi. Wasabi was good. Okay. So now that we've defined our sets, we can either calculate or just write down the number of elements in our universe. So the number of elements in our universe would naturally be the sum of any 2 disjoint sets. Okay? So we know that it would be the sum of any set plus the non-set. For example, in the classroom there's boys and girls, right? So in our case, we could add the number of boys and girls to figure out that there are 26 people. That's one way. Or you could find, the number of lefties and the number of righties, and you could add those to get the number of people in my room. But it's obvious that if you have 14 of one kind and 12 of another, that's a total of 26 people. But you don't want to pick an overlap. You can't figure out how many people are in my room by adding 15 and 4 or 15 and 5. That's not going to work because these are subgroups of the total, you see. All right, so obviously there's 26 people. You knew that right when you read it. that you're actually using this formula, n of k plus n of non-k is the universal set. Okay, so definitely 26 people. That's kind of our first question. The number of elements in set B. So what does that mean? What does n of B mean? Number of boys. So that'd be 12. Number of elements in set G is what? 14, right? Number of elements in the tough class, AP Bio, is 5, right? Number of elements in the sports category is, how many people playing sports did we say? 15, right? Now, notice my next question here is a yes or no question. Is n of u equal to n of t plus n of s? So can you count up the number of people in my room by adding those in AP Bio and those in sports? Yeah, if you did that, you would miss out on Jace. He's a very important member of our classroom, but he's not in AP Bio. He's not taking a sport. Not doing a sport right now. So how is that going to add up to the universal set? You see what I'm saying? So what is it about set T and S that don't allow us to add them together to get the whole classroom? Yeah.
Neither set T nor set S are all of the elements that are not in the other set. Like set T is not all the elements not in set S and all the elements not in set T.
Okay, that's like saying if I add two acute angles, are you always going to get 90? No, they have to be complementary, right? If the two angles are complementary, then they add up to 90. The same word is used actually for sets. Set T and S are not complementary. They don't combine to make the whole classroom. Yeah, they also are not disjoint. We've got a little overlap. We have some TS people, you know, some people who are in both AP Bio and also sport. So that messes things up. So the answer is no for two reasons. One, T and S are not complementary sets. That means they don't complete the package, okay, when they're glued together. So no, because S and T united is not the same as the universal set. You see what I just wrote? When you unite S and T, you do not get the universal set. The reason for this is twofold. One, S and T are not complementary, nor are they disjoint. Because S and T are not complementary. That means they don't complete the whole package. They don't make the universe. And S and T are not even disjoint. That just means there's overlap. So even if everyone in this classroom was involved in sports, and everyone in this classroom was in, or some of you were involved at least in big bio or sports, you know, that doesn't mean I can add the sports to the bio to get the classroom. It's not going to work because of those overlaps. Okay? So our goal now is to just write down a few things that are true. Okay? So let's write down a couple rules. If A and B are disjoint, that means they are not the same sets at all. There's not one single element that A has that B has, and vice versa. You can say that the number of elements in the union will be the number of elements in A plus the number of elements in B. Okay? If A and B are complementary, then you can go so far as to say that NAUB is in U. You get the whole universe by combining two disjoint complementary sets. So if A and B are complementary and disjoint, then combining them will give you the whole universe. Kind of like those who love fuzzy green hats and those who don't. Combined makes the whole population of humans. Of course, you have to ask a baby whether they like fuzzy green hats or not. My chances of getting a yes on that are pretty high, I think. Pretty sure most babies like fuzzy green hats. If they don't like the way they look, perhaps they like the way they feel. Fuzzy green hats. Who doesn't like the way a fuzzy green hat feels? If you don't like a fuzzy green hat, it's not because it's fuzzy. It's because it's green. Or it's because it's a hat. You don't like hats. Then you're a hat hater. Okay? Okay, so these are just some rules you can hang your hat on. These are definitely true. Now, if A and B are not disjoint, then the number of elements in the union will be the number of elements in set A plus the number of elements in set B minus the number of elements that are in both sets A and B. And if there's one formula you can memorize today, let it be this one. But here's what it's saying. Remember we said in our example, the number of students taking AP Bio was 5. That's the tough class, right? The number of students in sports was 15. If you want to find the number of students that are involved in sports or AP Bio, you cannot add 5 and 15. That will not work. Do me a favor, raise your hand if you're involved in either AP Bio or sports or both. So you're part of the union here. Raise your hand. We do not have 20 hands in the air. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Raise your hand if you're involved in either AP Bio or a sport or both. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's right. Yeah, 16. There are not 20, there are 16. Why?
Because the more people are involved in both.
Okay, so actually the number is 16 because the correct way to do this, yes, is to take the number in set T, which is 5, the number in set S, which is 15, and subtract off the number in both sets. So the correct equation is this: 5 plus 15 minus 4. Remember we said that there were 4 people enjoying both sports and AP Bio? You don't want to double count them. They're in the 5 and they're also in the 15. You only want them to be in one of those two, right? You don't want to count the same 5 people in with the same 15 people, right? Not all of them anyway. So this is the correct way to do it, and this gives us 16, right on the money. 16, not 20. So this is a really important formula. And you know what? If you had to memorize only one formula today, let it be this one, because if this last number happens to be 0 and the sets have nothing in common, then you just get the formula up above anyway. So you might as well memorize this one. Okay, let's draw a Venn diagram of Mr. Shore's class. Okay? Yes. So there's many ways to classify people in this room. We could do the fuzzy green hat thing. But we're going to stick with, this is the classroom, okay, this box. And so this is the universal set. So go and put a U in the corner. Okay, and then we've only discussed two subgroups in this room today. One was those who are in AP Bio. Now, how many people did we say were in AP Bio? 5. Okay? But we also had another group that was involved in sports that had 15. Now, is this the correct drawing? What's wrong with this picture? Yeah, we should have some overlap here. Okay? So in a Venn diagram, you want an accurate, meaningful representation. And if there are people involved in AP Bio and sports, you need to overlap the two circles to show that. Okay, so you already know this. Just even for your English classes, don't you draw Venn diagrams? Not anymore, but you've done it, right? So here's the way to do it, guys. You want to draw the two circles overlapping and title them, of course. So we have set T and set S. But you probably don't want to put that 5 there, because that 5 makes it look like there's 5 people in circle T that aren't part of circle S. You don't want that. So what you're going to do is you're going to break this 5 into two numbers, 1 and 4. Okay, 1 and 4. Why 1 and 4? Because we know that there are 4 people that are involved in both. Right? They're in both categories. So actually, this is the part you fill in first. You fill in the bothers in the middle. Then you know that there's 1 here. See, there's your 5. How many people are involved in sports again? 15. So that means you're going to need an 11 here. Notice that the sum of the elements, the number of elements in circle T is 5, and the sum of the number of elements in circle S is 15. And the 4 is in the middle. It's sort of the balance, the intersection. And now you can see the word intersection makes sense graphically. The circles actually are intersecting. Okay? The other thing about the Venn diagram is it shows us more than the rest of the work, because now we can also include people like Jace, or who else is involved in either sports nor AP Bio. Who else? Okay, you can raise your hand. We don't really need to poll the students. We know there's a total of 26 in the universe. So 1 plus 4 plus 11 is what? 16. There's 26 people in the room, so isn't there like a 10 outside here? 10 and 1 and 11 and 4, that's 26. So this out here represents those students that we weren't even discussing earlier. So this Venn diagram shows everything, including students not in the unions and the intersections at all. Okay? Do you think some math problems might actually start with the diagram, and then you have to write statements? Yeah, for sure. Definitely have that. We have problems where you start with a word problem and you make a Venn diagram. We have problems where you start with a Venn diagram and you write statements or even sentences. Okay? Notice every number here has a meaning. Can someone tell me what the 1 means? Besides Jackson. What does the 1 mean? It's the number of people in AP Bio that are not in sports. That's right. That's why it's in the AP Bio circle, but it's not in the sports circle. And that would be me, right? He is the 1. You're the 1. All right? What does this 11 mean, Cole?
That means that students only in sports.
Only in sports, that's a good way to say it. But they're not involved in AP Bio, right? So everything's meaningful. Do you suppose there might be some problems with 3 circles? Do you think you could read these sentences and fill in all the missing numbers here? Not as easy as it might seem. Okay, it might take you 20 minutes to do this. That's about how long it took third period. This problem says 200 people were asked which of these Grand Slam tournaments they'd attended. The tournaments inquired about were the US Open, Wimbledon, and Australia Open. 30 people had not attended any tournament. 10 had been to all 3. 25 had been to Wimbledon and the Australian Open. 20 people had been to the US Open and Australia Open, but not to Wimbledon. 65 had been to exactly 2 tournaments. By the way, that means no more than 2, no less than 2. And 165 people had been to the US Open or to Wimbledon. 120 people had been to Wimbledon or to Australian Open. So the goal is to fill in a number in each of these little compartments, including outside here, those who've never been to a tournament. You're going to do this on a piece of paper, and you're going to bring it to my desk and show it to me. If you get the solution right, you can start your homework, which is page 907. If not, back to the drawing board. So let me say one quick thing about the word and. And is intersect, and it looks like a football. See the little football right there? So when when you see the word and, look for a football. Listen carefully. If you see the word and, look for a football. That makes it easy to find in the picture. Don't miss what I'm saying. And looks like a little football. If you see something that says this and that, but not that, that's part of a football. This and that's a football. This and that, but not something, would mean a portion of that football. See the little football in the middle?
Yeah.
That is T and S. If you see further qualifiers like but not that, look for a portion of a football. Okay? Another clue is if you see the word or, that's a union. And you're going to be looking for soap bubbles. So you know what happens when you blow bubbles from a bubble wand, right? They go flying out in the air, and sometimes they stick together and they form something like this. This is a union. Yeah, a snowman. I always think of soap bubbles, but that's like a snowman, head and body, okay? Everything inside here is TUS. TUS is a total of 16 terms. TUS has 16. The little football in the middle, that little wedge, that's T and S, and it only contains 4 elements. I'm telling you, the football and the soap bubbles really, really helps you understand the sentences and find things quickly in the Venn. And one last thing before you start this, know that you're probably going to need variables. I actually needed to put X, Y, and Z into these compartments. So X is this portion, Y is this portion, Z is this portion. These red ones I kind of just figured out from reading very, very carefully. But in the end, to get X, Y, and Z, I needed 3 equations, 3 unknowns, and I solved a system of 3, like we did in chapter 10. This eliminates the need to guess and check, to try to balance the numbers like a Sudoku puzzle, when a person has no strategy, they're just guessing numbers, putting them in, and hoping it works, and if it doesn't, erasing. Okay? This is our strategy. We're going to make equations that use X, Y, and Z. It'll take a while to get to that. And I'll give you a hint, the last 3 sentences here are those 3 equations. Okay? The first 4 sentences are just clues to help you get the regs. And don't forget about this 8 given at the top. There are 200 people. Okay? So spend some time on it. I know the solution. Just bring it over to my desk, and I'll tell you if it's right or wrong. We get out today at 12:10, so got plenty of time. Okay, so for this problem, we need to probably think through it sentence by sentence. Okay, so there's a clue at the top here that you have 200 people, but I wasn't going to really use that first. The first thing I noticed is that a couple of these sentences contain information I can use immediately. So right here it says 10 people have been to all 3 tournaments. You can just put a 10 right in the middle compartment, right there. That little region technically is part of all 3 circles. Okay, so 10 right in the center there. And the other one that's pretty easy is 30 people have not attended any tournament. So you could put a 30 outside. So those guys are more or less given. Okay, so we took care of these 2 sentences. It says 25 people have been to Wimbledon and Australian Open. So whenever you see an and like that, you can think that the shape is going to be that like a football, shaped like a football. So basically, I'll shade it for you. It's Wimbledon and Australia Open. So this area right here, shaped like a football, is supposed to add up to 25. So far you can see we only have 10, so this must be 15 to keep it balanced. Okay, so now that sentence is true. 20 people have been to the US Open and Australia Open, but not to Wimbledon. So US Open and Australia Open would be this football region right here. See? But then it says, but not to Wimbledon. So you would not count this part. So basically, they're giving you this number right here. It's 20. Okay, so let's go ahead and clean this up a bit. So this is 20, 10, and 15 right in here. I'll use red, 20, 10, 15, and that takes care of this one. 65 people have been to exactly 2 tournaments. 65 people have been to exactly 2 tournaments. Okay, so the people who've been to exactly 2 tournaments show up in these compartments here. These 3 yellow compartments are for those who went to exactly 2 tournaments. You don't want to count the 10 in the middle because those people technically went to 3 tournaments, and when I say exactly 2, that means no more than 2 and no less than 2. So those 10 in the middle do not count toward the 65 people. Since I already have 20 and 15 in my 2 yellows down here, that means I'm going to need another 30 to complete the top. So now we know those 4 regions are 30, 10, 20, and 15. 30, 10, 20, and 15. And that takes care of this sentence. Okay, so everything's working out great. We're down to 3 last statements, the 3 blue ones, and those can be done by writing equations. So let's go to the very top here. Equation 1 would be 200 people. So you can write equals 200, and you're going to add up everything you see in the box. So you're going to add the x and the y and the z, and you're going to add the 20, and you're going to add the 30. There's actually 2 30s, aren't there? You're going to add the 15, and I think I got everything. And the 10. Okay, so if you simplify this, you get x plus y plus z is so this comes out to 95 because it's 50, 80, 95, 105. So you subtract that from 200. Okay, so that equation is ready to go. This here, I'll put a double asterisk next to it. That says 165 people have been to the U.S. Open or to Wimbledon. So U.S. Open or Wimbledon would be basically this region here. And everything inside it. So I call these soap bubbles. It looks like 2 bubbles stuck together. When you blow bubbles, you know, out of a wand, they float away, sometimes stick together. So you see the 2 soap bubbles there stuck together. That's how you find. The key word there is the word or. So or gives us the soap bubble look. Okay? But I can write an equation for that. We have x plus y plus the 20 and the 30 and the 10 and the 15. And this is all equal to 165. So this equation then simplifies to x plus y equals 90. Okay, and then the last one, triple asterisk here like this. Sometimes my stylus doesn't write too well when I get toward the bottom of the page. But this one is also an or. It's Wimbledon or Australia Open. So that's this region here. A little hard to see. I'll hash it in green. So basically it's all of this. Notice again, shaped like a snowman or two soap bubbles stuck together. But basically that is my third equation. That's supposed to add up to 120. So this is equal to 120. And it's x plus y. And then you've got the 20 and the 30 and the 10 and the 15 again. Okay? So this now tells us, oh, that should say z plus y, sorry. Y plus z, sorry. Can't even read my own handwriting. That's a z down there at the bottom. And that's a y over there. Okay, so this tells us that y plus z is okay, and then you add up the left sides, 50, 60, 75, subtracting 45. Okay, so the rest of this is actually pretty easy. You know that x and y add up to 90. So I'm going to go to the top of the board now. Since x plus y plus z is 200, or is 95, I mean. 95. And since x plus y, you know, is 95, I'm sorry, 90, you could just substitute that in, and you learn that z is 5. That means, since, remember, y plus z was 45, if z is 5, you can substitute that in, and you get y equals 40. And lastly, if you're looking for x plus y equals 90, and you already know that y is 40, you can see that x is 50. So the grand finale to this problem is you're going to replace the x, y, z with the numbers. And here is the complete answer to this problem. I'll fill it in. X was 50, right here. Y is 40. Z is only 5. 10 were in the middle, remember. Thirty's up here, 20's here, and 15's here, and there's a 30 on the outside. So if you add up all the red numbers, you can see it comes out to 200, and every one of these sentences is now true. All right? Now you might say, I could do that in my head. That might be true, but I would challenge you a little bit on that. Just understand that writing equations is an important part of a life. It's a life skill, you know. And algebra was invented so you wouldn't have to do so much work in your head. You're supposed to learn to write equations, even if you know the answer. Writing equations is just beneficial. So suppose this didn't have any numbers, and it was just all letters or something strange, then you would need to use symbols and not values anyway. So, I don't know. I guess my word to those who are really clever and can do these in their head, learn to write the equations anyway, learn to assign variables to things. Someday when you're an engineer or a scientist or something, that might be all you need to do. Okay? All right. That's the conclusion of 12.1. Don't forget to do the page 907. Oh, and I want to give credit to the author of this problem. So I'm going to scroll up so you can see the author. That was taken from math.tamu.edu. So here are my sources for that problem. Right there, and there's a video of their solution as well if you want to go see that. All right.